Have you ever wondered how a massive steel ship, weighing tens of thousands of tons, can float on water, while a small piece of metal sinks instantly? The answer goes back more than 2,200 years to a Greek scientist named Archimedes. He discovered a simple but powerful rule. Any object placed in water experiences an upward force equal to the weight of the water it displaces. This is called buoyancy. So here's how it works. If a cargo ship weighs 100,000 tons, it must push aside 100,000 tons of water to stay afloat. The ship sinks into the water just enough for the displaced water to match its weight, and that's when it floats. But ships are made of steel, so why don't they sink? Because they're huge and full of air. All that trapped air lowers the ship's average density. As long as that average density stays lower than water, the ship remains afloat. Problems start when water gets inside the hull. Air is replaced by water, the average density increases, and once it becomes greater than water, the ship begins to sink. That's exactly what happened to the Titanic. It had 16 watertight compartments, but when 5 were breached at the same time, water flooded in too fast, and the ship went down. Floating alone isn't enough. A ship also needs stability. If the center of gravity is too high, the ship becomes unstable and can tip over easily. If it's too low, the ship moves stiffly and doesn't respond well. That's why engineers carefully control cargo weight, hull shape, and internal tanks to keep the ship balanced. Even moving water inside tanks can raise the center of gravity and increase the risk of capsizing. Modern ships use advanced technology to stay safe: automatic pumps to remove water, ballast tanks at the bottom of the ship to maintain balance, double hulls to prevent leaks, and radar systems to reduce stress from waves. A simple experiment shows the same principle. Crumble a piece of aluminum foil, it sinks. Shape